Okay, so in this case, we've got a given amount of barium nitride, uh, so which reacts with H2O, of which you've been given the mass, and that produces barium hydroxide and ammonia, right? And we've been asked to calculate the volume that's going to be occupied by the ammonia that's produced in this reaction, right? So how are we going to work that out? Well, the question actually tells us that this reaction occurs at room temperature and pressure, and it also tells us the volume that's actually occupied by 1 mole of gas at room temperature and pressure, right? But we don't have the moles of the ammonia, which is what we need, right? So we need to work out what the actual number of moles are of the ammonia in order to actually, I guess, action this information. So we do have the balance equation, so that's going to be probably very useful in the process of trying to work out what's the actual number of moles. So what we can do, given that we've been told the mass of H2O that's actually reacting, and we've been told that the barium nitride is in excess, we can effectively infer that this is going to be the limiting reagent. The H2O is going to be the limiting reagent, and that would therefore have a direct relationship with the moles of NH3 produced. But we'll get to that. So the equation we're going to need to use here is the mass is equal to moles N multiplied by molar mass MR, right? And we'll be using this in the format of the moles. So if we divide both sides by the molar mass, we get that the MR is equal to then we get that the moles is equal to the mass divided by the molar mass, right? Yep. Okay. So we have the mass, but we don't have the molar mass, right? And in this case, we're looking at we need the molar mass of the H2O, effectively. H2O. So if we refer to the periodic table, should be able to work out the molar mass for H2O. So if we look at the relative atomic mass of hydrogen, so that's 1.0, and the relative atomic mass of oxygen 16. So the MR of H2O would simply be the relevant relative masses multiplied by the frequency of occurrence. So H2, so that's going to be 1 multiplied by 2, right? So and plus what relates to the oxygen in the oxygen case, which is going to be 16 times 1, right? And so if you work that out, you should find that that gives you 18, and the units for that is going to be 18 grams per mole, right? Okay, so using this value now, what we can try and do is effectively plug this into this equation, and in doing so we'd be effectively saying that the number of moles for H2O is equal to, and then we're going to do the mass, so it's 25.79 as given in the question, divided by the MR, which is 18, which we just worked out, right, for water. And that's going to give us the number of moles for H2O. So if you work that out, in my particular case, I'm going to round it. It gives quite a long number, a bunch of sevens, but at the end, but 1.432 777, and I'm not going to continue the row of sevens, but I'm going to just round the last 7 up to 8, so you just get 8, and that's going to be in moles, right? Okay, so but we've been asked actually to work out the NH3 produced, right? So how do we use this information? Well, if we look at the balance equation, you can see that for every 6 moles of H2O, 2 moles of NH3 is produced, right? So if you say, look at the ratio between the number of moles of H2O, no, thinking too fast, okay, number of moles of H2O, and in ratio of number of moles of NH3, you're going to have a ratio of 6, right, to, as you saw in the balance equation, to 2, right? And effectively, if we want to get, well, we want to get one side to be equal to 1, right? So, and it's going to be the left hand side. We want to get that equal to 1. And the way we can do that is simply dividing both sides by 6, okay? So divided by 6, you get what? You get 1 equals, well, 1 as a ratio to 2/6, right? Okay, which in other words is 1/3, right? So, and what can we do with that information? Well, what this effectively tells us is that if we multiply our number of moles of H2O by 2/6, we're going to get the number of moles of NH3, right? So if I formalize that in writing, basically the number of moles of NH3 is equal to the number of moles of H2O multiplied by 2/6, okay? So let's do that. So that's going to be equal to 1.43277778 multiplied by 2/6, all right? And that's going to be, so if you do have a go at working that out, you should find that you get 0.4775926, right? That's going to be moles, right? Okay, so we have the number of moles now. What did the question tell us actually? So the information we have is actually that for every given mole of the gas, we're going to have a volume occupied of 24 decimeters cubed. And effectively what this means is if we multiply the given number of moles by 24, we're going to get the value for the volume occupied by that particular gas, right, in decimeters cubed. So therefore, if we set this up and say the volume of NH3, I'm going to say therefore the volume of NH3 is equal to 24 multiplied by, and then this is simply the number of moles of the NH3, right? So 0.4775926, right? Which is effectively 11.46 2224, okay, and that's going to be in decimeters cubed, right? Now we have been asked in the question that when we do have our answer, that it should be to a maximum of 2 decimal places, right? So we're going to implement that, and if we round this, you can see the last number there is a 2, so that's simply going to be rounded down, and it's going to be 11.46, right? So equals 11.46 decimeters cubed to 2 decimal places, okay? And yeah, so that's going to be our answer in this case for the volume of NH3, right?